Here is a puzzle. A language model with 1.6 trillion parameters sounds impossibly large and impossibly expensive to run. Yet DeepSeek V4 is one of the cheapest frontier-class models to use, and you can download the actual model for free and run it on your own hardware. How can something that big be that cheap, and how can it be free at all? That tension is the whole story. DeepSeek V4 arrived as a preview in late April of 2026 from the lab DeepSeek, and it is just our example. The real subject is two ideas that now shape almost every frontier model. Light up only the small piece of the model you need on each word and let anyone hold the weights. Get those right and the price, the size, and the hype all fall into place. So let us see how it works, and where the easy headlines quietly mislead you. First, what's shipped? DeepSeek V4 is an open-weight large language model family built on an architecture called Mixture of Experts, which we will unpack. It came as two checkpoints, both under the permissive MIT license, weights posted on the model-sharing site Hugging Face. The big one is V4 Pro, the smaller one V4 Flash. MIT means you may use it commercially, modify it, fine-tune it, and redistribute it. Now the one set of numbers everything leans on. V4 Pro has roughly 1.6 trillion total parameters, but only about 49 billion activate on any given word or token. V4 Flash has about 284 billion total, 13 billion active per token. Both support a context window near 1 million tokens, about 1,500 pages, and both trained on more than 32 trillion tokens. Hold on to that gap. 1.6 trillion stored, 49 billion working, roughly 3% firing per token. That decoupling, huge capacity but tiny per token effort, is the spine of this whole explainer. And one flag. It is a preview, so read every figure as around this, mid-2026. Check the current value. So why does open weight matter? Because that is the durable lesson, still true years from now no matter the version. With open weights you get the train numbers themselves, the parameters on your own machine. No interface to call over the internet, no fee per request, no single company you depend on, and your data never has to leave your computer. Think who that helps, anywhere. A teacher, a doctor, a small shop owner, a researcher, each able to run a frontier-adjacent model privately, study it, and adapt it. But be precise, because the press blurs three things. Open weights means the parameters are public, so you can run, inspect, and fine-tune them. That is V4. Open source, strictly, means weights plus the training code plus the actual data and recipe to rebuild from scratch. And V4 is not this, because the training data and full serving stack were not released. Closed means you never get the weights at all, just a paywalled endpoint. So the right label is open weight, not open source. There is a famous moment behind this lineage, and it is worth telling as economics, not as anything else. In January of 2025, DeepSeek's earlier models, V3 and R1, triggered what was then the largest one-day loss of market value in history. The chipmaker NVIDIA fell about 17%, roughly $589 billion wiped out in a day, because the story was frontier-class AI apparently trained for far less compute than assumed. That cheap training number is contested, and it belongs to V3, not V4, so do not pin it on this model. But the principle outlives any version. Doing more with less compute can upend the idea that only the biggest spenders compete, and V4 continues that efficiency-first lineage. So what can it do? On paper, a lot. DeepSeek reports strong coding, agentic tool use, reasoning, and competition math, but everyone is self-reported under best-case conditions, so hold them loosely. The honest version. It is frontier-adjacent among open-weight models, ranked by one independent aggregator around third of dozens of open models. Leading among open models, but not the best AI in the world, and independent tests place it behind the closed frontier. Now the heart of it, the longest part for good reason. Picture a standard model, the kind called dense. Every word runs through the same one enormous block, the feed-forward block, so every token pays the full price. Mixture of experts changes that one move. Instead of one huge block, it uses many smaller parallel subnetworks called experts, with a tiny network in front called the router. The router looks at the incoming token and decides which few experts handle it. Only those run. The rest stay dark. Picture a long corridor of hundreds of doors, the router at the entrance. It glances at the passing word and opens only a handful. The token walks through just those and moves on. To put numbers on the corridor, each mixture of experts layer in V4 Pro has one shared expert plus 384 rooted experts, with 6 rooted experts firing per token. V4 Flash has one shared plus 256 rooted, again 6 firing. The shared expert runs for every token, a backbone always on, while the router picks just 6 of the hundreds for each word. So how does the router choose? It is a small network that looks at the current token and produces a score for each expert, a kind of affinity, how well suited each one is to this word. Then it takes the highest scoring ones. That is called top K routing, and here K is 6. The 6 best run, the hundreds of others switch off for that token. Now the headline number exact. Per token, the working parameters are the shared expert plus those 6 rooted experts. Roughly 49 billion active out of 1.6 trillion total, around 3%. The capacity, all the knowledge, lives in the whole pool. The per-token work lives only in the lit handful. But there is a problem hiding here. Let the router freely pick favorites and it collapses onto a few experts, which get all the training while the rest sit unused and never learn. So you must spread the load. V4 uses a balancing strategy that nudges usage flat across the pool, without the heavy penalty older methods needed. Picture the doors lighting up evenly down the corridor, not the same 5 over and over. 2 more pieces of how it was built. First, how the experts got smart. Rather than hope they emerge from one giant run, DeepSeek first cultivated separate specialist models in different domains: math, code, agents, knowledge, training each with supervised examples, and then reinforcement learning. Then they consolidated those specialists into the single unified V4 through distillation, where a student model learns to match the output behavior of teacher models, absorbing their skill. Second, the other efficiency lever, the one that makes a million token context affordable. Long context costs memory. As the model reads more text, it keeps a growing store of intermediate values, the key value cache, so it can attend back to everything. And for a million tokens, that cache would be enormous. So V4 uses a hybrid, compressed form of attention, 2 techniques layered together that shrink the cache dramatically. Picture a long tape of context squeezed down, a fat memory bar compressing to a thin one. DeepSeek reports that at a million tokens, V4 Pro uses only around 27% of the per-token computation and 10% of the cache memory of their previous model. Read that as DeepSeek's own measurement, not independently verified. Now the punchline that ties the mechanism to the money. What costs you compute when you run a model is the parameters that fire on each token, the active ones, not the total stored. So a forward pass-through V4 Pro costs roughly what a 49 billion class model costs in computation, while drawing on 1.6 trillion parameters worth of stored knowledge. That is the whole reason it can be cheap to run. Mixture of experts means fewer parameters fire, and compressed attention means a smaller cache for long contexts. Both do genuinely less work per token. It is not a magic discount. Picture a meter that ticks up only in proportion to that short active bar as tokens stream. You pay in compute for active, not total. Capacity scales with the total count, which makes a model smart. Cost to run scales with the active count, which makes it cheap. Mixture of experts pulls those two apart, and that separation is the real prize. It is also why this design now dominates frontier architecture. You can keep growing stored capacity while holding per token cost roughly flat. And now the single most important caveat, the thing that sounds smart but is almost always told wrong. Mixture of experts saves compute. It does not save memory. Here is why. The router might call any expert on any token, and you never know in advance which 6. So even though only about 49 billion parameters work on a given token, all 1.6 trillion must be loaded into memory ready the whole time. You cannot leave unused experts on a disk. Concretely, running V4 Pro means loading something on the order of 860 gigabytes of weights, which needs a multi-machine cluster of data center graphics cards. The smaller V4 Flash needs roughly 170 gigabytes, fitting on about 2 high-end data center cards, and that is the realistic self-host target. So picture the full corridor of doors all flickering faintly on at once, every expert resident in memory, while only 6 are brightly working. Memory full, compute tiny, side by side. The blunt conclusion: open weights does not mean it runs on your laptop. The tricks that kept a trillion parameter model trainable, special connection and optimizer methods, sit in the margin. Saving compute is not saving memory. Before we judge whether it is cheap, one clean distinction, because the whole question hinges on it. There are 2 completely different costs that people constantly blur. The first is training cost, the one-time price in computation to create the model. The second is inference cost, the price to run the finished model, paid every single time you send a request. Separate bills, like building a factory versus making each item once it runs. Mixture of experts directly cuts the second one, inference, because fewer parameters fire per request. For V4, the cheap claim is honestly true for inference, the running cost. For training, the building cost, it is contested. So whenever you hear an AI is cheap, the first question is cheap to build or cheap to run. Those answers can be wildly different, and they are verified in completely different ways. Let us take each in turn, because both have a trap. First, running cost, and here the cheap claim is genuinely defensible. If you call V4 through its hosted interface, an independent listing put V4 Pro at roughly 43 cents per million input tokens and about 87 cents per million output tokens, with a steep discount nearly free, on inputs the system has already seen, called a cash hit. V4 Flash is cheaper still, around 14 and 28 cents. That is well below the typical output prices of the big closed frontier models, and unlike a training cost claim, this is a published number you can check. So this is the real, substantiated cheap to run. But 2 caveats. First, that 43-cent figure has a history worth knowing because it shows how fast this moves. It started as a 75% launch discount off an original rate near $1.74 for input and $3.48 for output. And then, in mid-2026, the lab made the discount permanent, so the lower price became the standard one. The lesson is not the exact figure, it is that prices here swing by multiples in weeks, so check the current rate before you rely on it. Second, never treat any one price as permanent. Pricing here moves constantly. Now the building cost, and here is where almost everyone goes wrong. You have probably heard that DeepSeek trained a frontier model for just a few $1 million. Do not attach that to V4. That number comes from the earlier V3 era. What DeepSeek reported for V3 was a pre-training run of around $5.6 million in raw graphics card time. But that figure explicitly excluded almost everything else: the prior research and failed experiments, the salaries, and the full cost of owning all that hardware in the first place. Independent analysts estimated DeepSeek's true infrastructure spend far higher, server hardware well over $1 billion and hundreds of millions to operate the clusters. So that famous cheap training line is a contested narrative about an older model with most of the real costs left out. And there is no verified training cost for V4 at all. Picture a tiny $5.6 million tag on one small box, then the camera pulling back to a huge hidden iceberg of excluded costs. And remember, that market-shaking moment in early 2025 was about V3 and R1, not V4. The honest claim is cheap to run. not cheap to build. Now the most important lesson about reading any model's scores, the centerpiece of how V4 compares. DeepSeek reports a headline result of about 80.6% on a well-known coding benchmark called SWE-bench verified, which measures fixing real software issues. Strong, top open weight number, but self-reported under best-case conditions. An independent government evaluation retested V4 Pro on the very same benchmark and measured roughly 74%, below the leading closed models from other labs, and judged it to lag the frontier by about 8 months on a combined skill rating. The lesson is not which number is right. It is that the same benchmark, run by different testers, gives different numbers. There is a second trap. There are 2 versions of that test. SWE-bench verified is a curated few hundred task set that is saturated, where most frontier models clear around 70% and V4 reports 81%. SWE-bench Pro is a much harder contamination-resistant set, where V4 reports only about 55%. Same model, 81 on one, 55 on the other because the test is harder. So always ask who tested it and which version they ran. So how do you use it? 3 doors. 1. Call it through DeepSeek's hosted interface, just naming Pro or Flash, no hardware needed. 2. The door that makes open weights special, download the weights from Hugging Face and run the model yourself, with Flash the realistic local target and Pro needing a full cluster. 3. Use one of the many third-party hosting services that run the open weights for you, which exist precisely because the weights are public, and a version compressed by a hardware maker exists to run more efficiently. The middle door is the superpower the others lack. Now the honest limits. Trust the headline benchmark least, since real-world results land below the glossy self-reported figure. At its best, this is not a laptop model, because the top version needs a multi-machine cluster, so open weights does not mean it runs anywhere. The million token context is a ceiling, not a promise, since supporting 1 million tokens is not the same as flawlessly reasoning over 1 million, and long context recall remains imperfect across all models. And it is a preview, so scores, specs, and prices are all moving. State everything as around this and check the current value. Before we close, a quick myth check. 1.6 trillion parameters does not mean huge and slow, since only about 3% fire per token. Open weights does not mean it runs on your laptop, because all the parameters must load into memory. It was not trained for $6 million, since that is an older, cost-excluding figure for a previous model. Open weights is not open source, because the data and recipe were never released. 80% on the coding benchmark does not mean it fixes 80% of real bugs, since that is a saturated, self-reported subset. And it is not the best AI in the world, just frontier adjacent and leading among open models. So step back to the lessons that outlast this one model. Capability scales with total parameters, but cost to run scales with active parameters, and mixture of experts pulls those apart, which is why it now dominates frontier design. Open weights shift power toward whoever can run the model with privacy and no lock-in for anyone, anywhere. When someone says an AI is cheap, make them finish the sentence, cheap to build or cheap to run, because those are different bills verified differently. And read benchmarks asking who measured it and which version they ran. Here is the whole thing in one line. A trillion-parameter model you can download for free and run cheaply per token exists because of 2 ideas. Light up only the experts you need, and let anyone hold the weights. And the honest caveats that it needs serious hardware, that benchmarks vary by tester, that cheap means cheap to run and not cheap to build, are what turn this from hype into real understanding.